The modulation of index, also referred to as degree of modulation, a coefficient of modulation in amplitude modulation, it quantifies the extent to which the carrier wave's amplitude changes in relation to the message signal. This parameter is very crucial as it influences the quality and strength of the transmitted signal. In the previous unit 9 and 10, we discussed the concept of modulation, such as what is modulation, what is the importance of modulation, and then we discussed about the types of modulation. It is analog modulation and digital modulation, and we further analog modulation, amplitude modulation, frequency modulation, and phase modulation. And then unit 11, we start our discussion about amplitude modulation. Now we are moving little further in unit 12 and we will discuss the index of modulation. It has a different name, depth of modulation, coefficient of modulation, and still it is a part of chapter 2 of our syllabus. The modulation index or degree of modulation in amplitude modulation is a qualitative or quantitative measure that defines the degree to which the amplitude of the carrier wave, which is varied in response to the modulating signal. It directly impacts the efficiency and quality of the transmitted signal and display a crucial role in determining whether the signal is properly modulated or distorted. So we simply determine the index of modulation as denoted by m, or sometimes it is mu, in given by the formula that m is equal to Vm divided by Vcm, where Vm is the amplitude, maximum amplitude of the modulating signal, we also call as a message signal, and Vc is the peak amplitude of the carrier signal. And both message signal and carrier signal are sinusoidal, so their amplitude are continuously vary with respect to time. But here we will consider only maximum amplitude of the message and carrier signal to determine the index of modulation. The modulation index, as it is a ratio, so it has a no unit and typically lies in the range of 0 to 1 for ideal amplitude modulation. However, it can exceed in certain cases, and but this leading to overmodulation and causes some distortion or noise. We will discuss in the next slide. The value of modulation index m or mu can range from 0 to value greater than 1, and each range has its effect on the amplitude signal itself. Firstly, we discuss about undermodulation, where m, yani modulation index, is less than 1. The amplitude of the modulating signal Vm is smaller than the carrier signal, which is Vc. The envelope of the modulated signal does not fully utilize, as shown in the figure, the carrier wave's amplitude range. While this prevents distortion, it leads to inefficient use of carrier wave and reduces the strength of the transmitted signal. Similarly, the resulting AM wave look like some compressed wave and may result in weaker signal detection at the receiver. Now we discuss about perfect or 100% modulation where M is equal to 1. The amplitude of the modulating signal Vm matches exactly the amplitude, yani maximum amplitude of the carrier signal Vc. The carrier amplitude varies exactly between 0 and twice the carrier amplitude. This is the ideal case in amplitude modulation. Provide maximum efficiency without distortion. The envelope of the modulated wave perfectly represents the message signal. Now we discuss about overmodulation, where m is greater than 1. The amplitude of the modulating signal Vm exceeds the carrier amplitude Vc, and this causes distortion because the modulated wave's envelope overlap leading to the envelope distortion as shown in the figure here. So over overmodulation result in the loss of the information, making it impossible for the receiver to reconstruct the original signal accurately. This condition should be avoided to ensure the clear distortion-free communication system. Degree of modulation is a simple index of amplitude modulation play a vital role to define some parameters such as efficiency, sigma clarity, and power distribution. We will discuss one by one. Firstly, we discuss about efficiency. For efficient modulation, our modulation index should be ideally too close to the one. This ensures that carrier wave is fully utilized while avoiding distortion. Similarly, we discuss about signal clarity. For signal clarity, a modulation index m is equal to 1 ensure that the transmitted amplitude modulation signal is free of distortion, leading to high quality reception at the receiver end. Now we discuss about power distribution. In amplitude modulation, the total transmitted power is distributed between the carrier and sideband. The modulation index also affects the distribution of power, and we can determine this transmitted power is equal to PC 1 plus m square by 2, where PC is the carrier power and PC is the transmitted power, and higher M means that more power is transferred to the sideband, improving the signal information carrying capacity. Now we are interested to solve a simple numerical where a carrier signal has amplitude of 10 and modulating message signal has a peak voltage of 6 volts. What is the modulation index? And the system is under modulated, perfectly modulated, or over modulated. Question is very simple. We are given the maximum amplitude of carrier signal, which is 10 volt, and message signal, which is 6 volt. Now, the modulation index is the ratio of AM over AC, which is equal to the zero point 0.6. Now, zero point 0.6 is less than 1. So we can say that first, you determine the modulation percentage, which is m multiplied by 100%, which is equal to the 60%. So now our modulation index is less than 1. So we can say that system is under modulated.